moving on now. I was going to try to squeeze a test in. I'm going to try to squeeze a test in, I think, Friday. Otherwise, it's got to be the Monday we come back. Okay. It's not going to happen. Delay might be okay. You know, that snow day calculator stinks, just so you know. It said it was a 50% chance on like Friday last week. So, who are you? And how did you? Okay. So here we go. All right. So functions and logarithms. So one-to-one functions. Now these are all reviews. So we fly through these things because these are things that you should know. You know what I mean? I know some people don't, but hey, what are you gonna do? Okay. So if I have a one-to-one function, what does it pass? What test or tests does it pass? Vertical and horizontal. Because vertical line is for what? For the function, right? Horizontal is for the one-to-one. Okay? Determine whether each of the following functions are one-to-one. So they already tell us it's a function. Okay? So one-to-one horizontal line test. You should not need your calculator for any of these. Okay? You should know what these look like. So we have the first one, which is an absolute value. What does absolute value look like? V, right? Absolute value, the V for value. Okay? So it looks like that. I don't care if you put it on the graph or not. Okay? So yes, it's a function, right? But no, it is not one-to-one. Okay? So you got to be very careful. Whether they are one-to-one, no, the first one's not one-to-one. Okay? The second one's a square root function. What does a square root function look like? Yeah, your half bird, okay? So it looks something like that. Okay, there it is. Has a starting point, okay, and moves on. Generally to the right. Okay? Is that one-to-one? Yes. All right? You might look at this and say, oh, look, it tapers off. Yeah, it kind of tapers off, but it's still increasing. Okay? So no matter how small you go up in the x-axis, it's going to go up ever so slightly in the y-axis as well. Okay? So it will be one-to-one. X squared is a what? Parabola. Nice and easy, right? Okay? Any x squared, that's what it's going to look like, something like that. Oh my God, is that Emily again? What a freak. Oh my gosh. You know? All right, so one-to-one? No. Okay, so we have a no, yes, no. All right, so there's your review on one-to-one functions. Okay? Inverses. Okay? So with your inverses, remember your original f of x versus, okay? Sometimes you'll say like y prime. Okay? What do? Switch the x and the y and solve for y. Inverses are reflected over the line y equals x. So if I want to find the inverses of the following, you switch the x and y, solve for y. Ooh. Okay, that's your inverse. Okay, switch your x and y. And I'll show you all the steps here. Oh my gosh. I don't know what happened there. This is so sensitive. Okay. What's so funny? Sure. Square both sides. Okay, there's your inverses. Okay. That's fine. Yeah, that's fine. Yep, those are good. Yeah, that's fine, and it's either one is acceptable. Okay. And you know something. There's no rhyme or reason in this book. You know how they have it. Sometimes in the back of the book they have it like that. Sometimes they'll separate them. The only time it has to be separated is if you say A plus BI form. Okay. Now let's take a look at page 40. Because sometimes they're going to say prove or verify that they are inverses. Okay, so we might give you two separate equations, and you'll have to prove their inverses. Okay, so here is the first one. Here is the second one. If you look at step 2 at the top of page 40, where it says f inverse of f of x, and then below it says f of the f inverse of x. Okay, so to prove that something is an inverse, you have to take, so I'm going to say this is 1, this is 2. You have to take 1, plug it into 2. Then you take 2, plug it into 1. Okay, meaning that, okay, this here, y equals x cubed. Okay, so we're taking it, so if you see like interchange, where do they have it? They have the 1, I got to put these on. All right, so they have the 2x, negative 2x plus 4, right, and step 2. And you see how they have 1/2 x plus 2, right? So my f of x is, you take your 1/2 x. So they did the negative 1/2 x plus 2. And you see how they plugged right in the negative 2x plus 4 plus 2? Okay? And then they did the same thing for the other one. So what they do is they plug it in. So if I take this first one and I plug it in, so I'm going to plug in for x, the x cubed. Okay? So what that gives you, it gives you x. All right? So when you plug them in for each other, it's going to give you x. Just like if I take this second one, root of x, and plug it in for x cubed, same thing, these cancel, and it gives you x. So when you plug it in for the corresponding x, it is going to give you an output value of x. They both have to give you x. Okay? All right, and if you're going along, that's fine. Here's 1. Here's 2. Okay? So we take 1, put it in for 2. So maybe I'll switch colors. Oh, what was that? No, I guess. Okay, there it is. All right. So we take this and plug it in for the x. So 3x minus 6 plus 6 over 3. These cancel. 3x over 3 is x. Okay? Then for the next one, you take 2, plug it back into 1. So we have 3x plus 6 over 3 minus 6. Okay? These cancel. The 3's cancel. Then I have x plus 6 minus 6, which is x. So either see what you said is true, right? But then it'll get a little more complicated when you go to plug that in. Yeah, okay, so that's when you're verifying. It gets a little more complicated. Okay, is that all right? Everyone got the gist of that? All right? So again, that's how you would prove. So if I gave you two functions and I say, are they inverses of each other, that's what you would do. You just plug one in for the other and the other one in for that one. Okay? You got to do both. Okay? Because sometimes you might end up with an x, and the other one might give you a negative x. All right? So you got to be very careful. It always gives you x. They're just not inverses. Yeah, that's all. They're just not inverses. Okay? Your log functions. Okay, some things that we need to remember about logs. If we give you log y equals log a of x, the inverse is y equals a of x. Okay? Or a to the x power. All right, so when we're talking about inverse, what I do with the logs, okay, if this is my given and they want me to find the inverse, okay, all I do is throw away the log. See that? And then look, it's just y equals a to the x power. Okay, if I'm looking for an inverse. Okay, does that make sense? All right, and then the same way, if I start with this, boom, I just throw a log in. Okay, to get your inverse. All right, makes sense? Yeah, ln of x is the natural log, la la la. Yep, common log because it's a log base 10. We talked a little bit about this yesterday, I think, right? Okay. Solve for x. Now, you want to go as far as you can. So with this one here, if they say solve, we want to get x by itself. Okay. we got to get rid of that ln. All right, so how do I get rid of that ln? It's way back here. Remember this? Where we do a to the x equals b. These are equivalent, not inverses. Okay, those are the same thing. So if I have a single log, I can eliminate it by changing it to a base power. So to change this natural log, right, what do I have? I have e to the 4t plus 3 equals x. That's changing it. Okay? And that's it. There's two different variables. They just want to isolate the x. We did it. We isolated the x. Okay? Now, you have e to the 2x. So now you're thinking, oh my God, I can do what I did up here. No, no, no. We're not going to do that. Okay? You have to see what is given. Since the x is in a power, you have to take the log of both sides. And since this is a base e, we do with a natural log of both sides. And then what's the natural log of e? 1. Where does the 2x go? In front, right? Power rule. So 2x equals natural log of 12. Divide by 2. Divide by 2. X equals natural log of 12 all over 2. Okay? Sometimes you'll see that in the back of the book. That's fine. Okay? If it says to nearest tenth, nearest hundredth, whatever, then you just evaluate it, put it in your calculator. Do not tell me that the natural log of 12 over 2 is natural log of 6, because that is not correct. Okay? And I think when you put this in, you get approximately 1.242. Okay? And I think we plugged those in yesterday. We did a couple logs yesterday in the calculator, all right, with the practice. And you just plug it in. It just, you know where the natural log is. And remember, calculus uses natural log versus log base 10. All right, it's the same thing, but they like using a natural log because E becomes more prevalent in calculus and higher levels. Okay? Rules, properties. Okay? Remember, you kind of distribute through. So if I have the product rule, multiplication becomes addition. And what you do is you distribute that log to both parts. All right, so it might be like a 4x. Oh, I got A is 4, B is x. Okay, separate them. And then same or similar, the division becomes subtraction. They kind of go hand in hand. Again, you're distributing it through. Okay, and then if you want to go backwards, you kind of factor it out. Okay, and then here's your power, where the C comes out in front. That's your power. Okay. There is one thing. Graphing it, I'm not worried about it. You graph it. So let's put it in. Go ahead. I don't think I have my calculator up. Let's go ahead and plug that in and see what it looks like. And then I'll go back and touch on something else. Does everyone know how to do it? You got the log base 4 of x. Okay, let's see. Good. I like it. Okay, what does it go through? What point does it go through? 1, 0. Okay, so let's go back and take a look at what I discussed. So everyone should have it going through 1, 0, correct? So when I looked at, see this right here? Okay, so this 1, 0 is kind of like that, right? Okay, but it goes down here, right? It doesn't touch. That's your asymptote. Okay? Y equals A to the x. Okay? A is greater than 1. Where does this pass? Through what point does it go through? We talked about this yesterday. 0, 1. Okay, so here it goes through 0, 1. Okay? And as long as your A is greater than 1, what happens? It's like this, right? Right? Like that? Yes? All right, that's your exponents. We talked about that with the exponential expressions and equations. All right, whether it's greater than 1, or remember, if it's 1 or 0.5, 0.75, it goes the other way, it goes down. Okay, inverses are a reflection over what? Look, see here? See that? Does that make sense? Okay. So that log, what do we have? We had y equals log 4x, right? Okay, that is this equation right here. Okay, What's the equation of this line right here? What's the equation of it? Y equals 4 to the x. Okay? And you could validate that by putting in your calculator. All right? And you could see that it reflects. And then if you put the line y equals x, you could see that it is a reflection of the line y equals x. Okay? So that's why the log works like that. Okay? Because it is the inverse of your exponent. Okay? So, all right, here's a couple applications of the logs. All right? So little, again, I keep referring to yesterday because it's just, little review. This, again, deals with growth and decay. All right, and this one down here, also growth and decay, but be very careful of the formulas. Compounded annually, I don't have to worry about how many times per year. Okay, so that n, that comes into play. We don't have to. Okay, so how would I set this up for Harrison if he wants to reach 10 grand? Remember the formulas we used for growth and decay yesterday? With the A? Remember, what did A really mean? A was what? 1 plus or minus the rate, right? Okay, that was the A. Okay? So we are investing. Investing money generally means you're going to get a return on it, generally. Okay? Not always. If you play the market, you could trip and fall. Okay? So let's see what the Harrison pal has. Okay? Based upon yesterday. What, 5 grand? So what essentially is happening here? His money, he wants his money to what? Double. Okay, so this is another way to ask how to make his money, or how long does it take for his money to double. What does the X stand for? X is what? Time in years. Okay, usually it's in years, right? If it's in days or months, all right, we saw some of that yesterday. So use your logs, see if you can find T. You go to the nearest tenth is fine. Anyways. All right, what do we get? We got 14.9. Okay, so about 15 years. All right, good. All right, and you use your natural log. Of course, bring this over. You had the 2, so then ln2 equals x ln 1.0475. Okay, and then just divide them. All right, plug them in your calculator. Next one. What formula do we use here? PERT. Okay, how do you know it's PERT? Yep, compounded continuously. Yep, okay. So how long will it take it to reach 3 grand? Okay, interest 5.05. You got to be careful with this one. Is there a 1 plus or minus? So eventually got 3 equals e to the 0.0505 t. So what I want to happen is I want it to triple. Okay? So because it started at 1,000, it's got to equal 3 grand. So, what do? You just got to divide. Okay? So the 3,000 divided by 1,000 gives you the 3. I want it to triple. I want it to double. That's 2. Sometimes it's not as easy and you get decimals, so that's fine. How to get ln of 3 equals 0.0505t? Yeah, very good. Plug both sides, you power ruled it. ln of v is 1. Okay? Now, any additional steps that you need to show on your paper in your notes, make sure you show it. Okay? If I go too fast and you don't know where a step came from, ask me. Maybe I'll put it up there. Maybe. Let's see what kind of mood I'm in. You know what I'm saying? It depends who's here. You know what I'm saying? Because this is the formula here is a PERT. PE raised to the RT, right? The rate stays the same. When you're talking about growth or decay, that A is 1 plus or minus, because the 1 accounts for the original amount. Okay? So there is no 1 here. because we have the E, the base E. Okay, that's how you do compounded continuously. Okay, bless you, person. Okay, and what do you have, like 21, would you get 21.8 years, roughly? Yeah? Okay, so look how long it's taking, right? How taking things to grow, invest, right? So when you guys get out of college and you get a job, you want to start investing a little early. You know what I mean? You want to start investing early. So that way when you're ready to maybe throw in the towel, okay, you got a good nest egg. No, we're done, but this is not. This is little. This is little. This is just putting. You got a grand. You know, you graduated from college. You put $5 grand in the account, and you just leave it and you walk away. You know what I mean? And then in 20 years, wow, look, it tripled. Okay, so you got a little bit of, oh, look at that. I can buy. At that point, you might be able to buy a candy bar. I don't know. You know, so that's about it. You know, so yeah, yeah, exactly, right. All right, a chair maybe, or maybe a dust bunny. Oh, I haven't some Murgatroyd even. All right. So let's do this. Let's in the calculator. Now you can't do. We're not gonna be able to do this manually like we did the exponential one because of the reflection. Okay, over the y equals x. So let's plug this in with this year being 0. Okay, and see if you can get your logarithmic regression equation. Yep. So 7, 8, 9, 10, 11, because 1990 equals 0. I went 3 decimal places. I mean, usually good rule of thumb is you go 1 decimal place further than the original data. Okay, stats people will know what that. And you get what? You get yeah, I got 0.373, right? Because we went 3 decimal places. Okay, and if you go more, that's fine. More is good. Less, not so much. Plus 0.611 ln x, right? Can't see ln x. Yeah, I was going to say, if you put the cursor on it, right? It shows you at the bottom. Just like, did we look at the 1? Or was in this class we looked at the 1? Yeah, it was like 9. Yep, okay. Yep, 7, 9, 9, 7, 3. Okay, so that would be your equation, and then estimate the number of cubic feet in natural gas produced by Saudi Arabia in 2002. So what would my x value be? 12. Okay, x would be 12. And then find your output. The output, 2 decimal places, it's okay because that's what it has in the original. Okay, if you round too early, you're not going to be as accurate. What'd you get for your output? 1.89, right? Okay, 1.89 trillion. Okay, now, I think we looked at it yesterday. Does that make sense in the context of your other output values? Yes, it does. Why? Because it fluctuates. Look, from this one, from the first to the second, what does it do? It goes up. What happens here, though? It goes down. Okay? This one goes up. This one goes up. This, right? Because it's really like a line of best fit, right? And there's a, so if you have it, okay, you have points above and below, which should happen. Okay? All right, makes sense? All right, so that'll be it. We'll talk, I'll give you the assignment class, and then I won't do another lesson until tomorrow, and then we'll see how we are, you know, with that 2-hour delay tomorrow or whatever.